Alright, so this is going to be a video tutorial on the properties of the three basic types of trigonometric graphs. So I've divided each graph into three separate columns. So we have our sine x graph, cos x graph, and tan x graph. And we also have a bunch of things to write down for them. So the D's are going to represent the domain, the R is going to represent the range, the A is going to represent the amplitude, AOS is going to represent axis of symmetry, the P is going to represent the period, and then you have the maximum and minimum values for the functions. And this is just covering the base functions with no transformations. So to start with the domain, for sine x and cos x graphs, the domain is always going to be infinite, and it's always going to be an element of real numbers. And that is because the graphs are cyclic, meaning that they infinitely repeat over and over again. Even though they can only represent one cycle, or let's say 2 or 3 cycles or 4 cycles even on a graph, that one cycle is just going to infinitely repeat. And like an example of this, just to kind of visualize it, is if you have like a pendulum swinging, one full swing of a pendulum could represent one cycle of, let's say, a sine x graph. But if that pendulum keeps swinging, the graph is going to continue the same way. And that's the reason why the domains for both of these functions is simply just going to be xer. So x is an element of real numbers, because x is going to continue infinitely to the positive and to the negative sides. For the tangent graph, though, it is different, and that's because for every pi over 2, starting at pi over 2, and then adding a pi to that causes asymptotes to form at every one of these points. And because of this, we can say that x is an element of real numbers, so x can be anything, except x cannot be pi over 2, and because you can clearly see on the graph that at pi over 2, we can't have any x values. So that covers this pi over 2, but it doesn't really cover all the other ones that are on the graph, and that will infinitely repeat. So you can kind of use a math notation to help represent that. And the math notation you can use is to say that x cannot be pi over 2 plus n pi, or pi n, where n is an element of the integers. So what this means is so starting at pi over 2, if you add a pi, it could either be 1 pi, 2 pi, 3 pi, 100 pi, or let's say negative 4 pi, negative 8 pi. Any pi value that you add that is a whole like pi number, so 1, 2, 3, 4, or negative 1, 2, 3, 4, there's going to be an asymptote where x cannot be equal to that pi. And that's why I also wrote n is an element of the integers, because n has to be a whole number. So that finishes the domains for the functions. Next, the range. So the range for the basic sine and cos functions are pretty simple. Y can be an element of the real numbers, and y has to be between -1 and 1, because you could just take a look at the graph. You can see the lowest point is at -1, and the highest point is at 1, and this is the same for both functions. So I'm just going to quickly write that down. There we go. And then for the tan function, even though it doesn't show on this graph, the tan function actually has an infinite range, meaning that the range for the tan x, you can either say y is an element of real numbers, or I think a better way of saying it would be that it has a range of -infinity to +infinity. And that's because, let's say, starting at pi over 2, so if you go a tiny bit further from pi over 2, your tan x function is going to be down at negative infinity, and it's going to keep going up until it reaches positive infinity, and it's going to keep going up forever and ever, approaching that asymptote right next to it, and then right when it hits the asymptote, and then a bit beyond that, it's going to go back down to negative infinity. So it's actually constantly switching between a positive and a negative infinity for the range. All right, now for the amplitude. So the amplitude of a trigonometric function is how tall the function is from the axis of symmetry, basically. So looking at the sine and cosine graphs, you can see that the axis of symmetry for them would just be down the middle, right? That's where you can split the function into two equal halves, right? So the amplitude would just be a measure of how tall it is from this point right here up until either the highest or the lowest point, but most of the time is the highest point. So this. So it's just a measure of this point right here. So to find the amplitude, let's just go down a little. You can do a type of math formula for it where you say if you do the y max minus the minimum and you divide that by 2, you get your amplitude. That's the main formula you can use for amplitude. And so looking back at our sine and cosine graphs, you can see that our y max is 1. So let's just do this here. So 1. And then our minimum is negative 1. So minus negative 1 divided by 2 would be equal to, so this becomes positive. 1 plus 1 is 2. 2 over 2 is 1. So the amplitude for the sine x function is 1. Sorry. And the same thing applies to the cos x function. So the max is 1. The lowest point is negative 1. So same thing. Your amplitude is also going to be equal to 1. Now, for the tangent graph, there isn't really a known altitude that you can give it because it grows infinitely, so you can't really put a measure on its range. So I'm just going to put an NA for the amplitude. Now, it is different if you have an equation with tan, because later on in the next lesson, the transformation lesson, you're going to learn what parts of the equation of like a sinusoidal equation represent what value, such as like amplitude or phase shift or period. And you can kind of say that there's an amplitude for tan, but there technically is no real amplitude for tan functions. Now for the axis of symmetry for these three, the axis of symmetry, it's going to be kind of what we did earlier, where you split the function down the middle, and that's so you can get an equal top half and bottom half of the function. So the formula for the axis of symmetry, to find that, if it's not really easy to just look at the function, is similar to the amplitude formula, but there is one difference. So for the axis of symmetry, the formula is your y max plus your y min over 2. So that's the formula for your axis of symmetry. And that's different from amplitude, which is y max minus y min over 2. So that one sign, the plus rather than the minus, is kind of what changes the way that the axis of symmetry is found. So with that being said, we can plug that into our graph, so sine x cos x. So it's going to be y max plus y min, so the max is 1, plus the min is negative 1 over 2. That's going to be equal to 0. So the axis of symmetry is 0, which makes sense because at 0, when y is 0, our graph is split into 2 equal parts from the top and bottom. And then the same thing is going to be for cos x. Axis of symmetry is just going to be equal to 0. Most of the properties of sin x match cos x, but tan x is the only one where it kind of gets a little tricky from the base functions. All right, now for our special tan x function. So because tan x still doesn't have a maximum or minimum point, as it goes both towards positive and negative infinity, we can't say that it has a horizontal axis of symmetry. So I'm also just going to put NA. But tan x does have vertical symmetry, where for every pi, the function is equal to the pi before or after it. So if you're looking at it in degrees, every 180 degrees, so this would be 90 degrees, this would be 270, and for every 180 degrees, the function is going to be symmetrical across a vertical axis. All right, next for p, so the p is going to represent the period, and to find the period on a graph, you can mainly just look at the function if it's a easier function. So for your basic sine and cosine graphs, if you can find any one point on your sine or cosine graphs, and as long as you find the second point where it matches up with the first point, where it completes one full cycle, then you can find the period. So what that means is, let's say you look at the sine x graph, right? So the sine x graph, you can see that it starts at 0, and then it goes all around, and it ends at 2 pi. So this means, so this black line that I drew here, this means that for every 2 pi, there's going to be one full cycle. So the period is 2 pi, because it takes 2 pi to complete one full cycle. So let's just put 2 pi for the period. But you don't have to look at it at that point. You can look at it at any point that will eventually end up back to where it started. So for example, you can also look at peaks. So you can look at, let's say, this bottom peak down here, and then you can also look back to this bottom peak. So if you go all across, all around, you can see that it starts at negative 2 pi and ends at 3 pi over 2, which means it went across for one cycle 2 pi. And then the same logic is going to apply for the cos graph, or any graph really that is sinusoidal. So the cos x, so you can start here, ends here, one full thing would be one cycle, which is starts at 0, ends at 2 pi, that's 2 pi. So I'll just write 2 pi for both. Now for the tan function, as I said before, for every 180 degrees the function will repeat, which means if it goes, let's say, from negative pi over 2 to pi over 2, then one cycle is going to be pi. Each cycle is going to be pi long. So this is going to be pi, this will be pi, this is going to be pi. It all takes 1 pi to do one full cycle of tan x, which is 180 degrees. So the period for tan functions are pi. And finally, the maximum and the minimum, this is just pretty simple. You just look at the maximum point. So for sine and cos x, it's just 1. And then for the minimums, it's negative 1. So you just look at the graph, negative 1, 1. So you do negative 1, negative 1. And then for the tan x graphs, there is no maximum and minimum. So for the maximum and minimum, for tan x, you could just say infinity or negative infinity. So I'm just going to actually replace the max and the min, and I'm just going to say, actually I'm just going to put max slash min, and I'm going to do plus or minus infinity, just to show that because it has no uppermost point or lowermost point. And those are the basics of the main trigonometric functions. The tan x doesn't really come up all that much for properties, but the sine x and the cos x is definitely more important to know these two, I'd say. These two, it's more important to kind of know, to kind of get the basics down, because tan x is kind of like the outlier of the group. It's a bit weird, but the other two are definitely things that should be reviewed heavily. And that concludes this lesson. Next lesson, we'll be learning about transformations, so how to graph a graph from an equation, or how to write the equation of an already existing graph with different things like different amplitudes, different periods, and all that stuff.